Hello everyone. This video is on the Knewton Alta assignment, section 2.6, part 3, called Absolute Value Equations. Alright, so in this video, I'm going to be going over a preview version of this particular assignment. Now please understand that the questions I see in this video may not be the same questions you see when you work on the assignment yourself. But the objectives are the same, right? So the questions should be similar. So I'm hoping watching me go over a few of them will help you in some way when you work on the assignment yourself. Alright, so this is your assignment page, right? You got the title, your mastery bar, you can see the objectives. Wow, it looks like there's only the one objective, which is, hopefully this will be nice and short. Solve absolute value equations. Then under the current objective, you should have a question related to that objective. And underneath every question, you should be seeing a feedback button where you can send feedback to Knewton about like typos or something wrong with the question that you see. You will not have this instructor cheat button, right? This is for instructors only. You will have the more instruction button that you can click on if you're struggling with a particular topic, and it'll take you to a page with some reading to do or some videos to watch, and then you have questions related to that instruction. Right, so and you can get through the assignment, progress through the assignment that way if you wish. If you want to do, you can use more instruction for every question. There's nothing wrong with that. Okay, so again, there's only the one objective here. All the questions should be on this, solve absolute value equations. So in each of these equations, you're going to see the absolute value symbols. Right, these is two bars, two vertical bars, and an expression with some variable inside, inside that absolute value symbol. All right, so I'll write this equation out on paper and talk about the steps I'm going to be following to solve these absolute value equations. So we're given the absolute value of negative 9x plus 8. All right, so again, absolute value symbols. Now equals 8, equals 8. All right, this is getting kind of faint, sorry. Grab another marker. Now, a common mistake people make is they think, oh, absolute value, that makes everything positive. So they'll say, absolute value of negative x plus 3 or something. They'll say, oh, that's just equal to x plus 3, right? They just make all the coefficients positive. This is not true. Do not just do that. Don't just make every coefficient positive. Because look, what if x were 2 or something? Right? If x were 2, this side would be the absolute value of negative 2 plus 3, which is the absolute value of 1, which is 1. This side would be 2 plus 3, which is 5, and those are not equal. All right? So please, 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 don't just make all the coefficients positive. This is not 9x plus 8. Right, leave it in the absolute value symbols. Alright, so for solving these absolute value equations, right, I'll put some steps up over here. Alright, the first thing we're going to do is isolate the absolute value expression. So you'll have the absolute value of, some expression equal to something else. I'll call this n over here. Right. But you have the absolute value alone, nothing multiplied, nothing that's multiplied by, nothing that's divided by, nothing that's added to or subtracted from. it's all alone, equals, something else, which I'm calling n. So this is exactly what I want to start. This equation they gave us. Absolute values alone, nothing around it, equals something else, right? Equals 8. Now, if the absolute value of some number, some expression, equals another number, then we're going to set up two separate equations. Remember, the absolute value of like 8 equals 8, and the absolute value of negative 8 is also 8. Right? Absolute value just kind of, is the distance from 0. It's always non-negative. So it turns positive numbers into themselves and negative numbers into their opposites, back to a positive number. So we're gonna say that the absolute value of some expression is equal to n if that expression is n itself, or if that expression is the opposite of n. And then the third and final step is going to be to solve these equations, right, these two, and check. Of course, you always go back to the original equation and check your solutions. All right, and these are the steps I'm going to be following for all the equations in this video. All right, so when I say the absolute value of negative 9x plus 8 equals 8, then negative 9x plus 8, that it could be 8 itself, right? Because the absolute value of 8 is 8. Or negative 9x plus 8 could be negative 8, right? The absolute value of negative 8 is also 8. So one of these two things could happen, or both. And then over here we get x equals 0. All right, subtract 8, divide by negative 9. Or over here, subtract 8, you get negative 9x equals negative 16, then divide by negative 9, x equals positive 16/9. But check them. Right? Don't forget to check them. Now, I'm going to do this first one on paper, and the rest of the problems I'll just do out loud. I'll just do mentally. When x equals 0, we have the absolute value of negative 9 times 0 plus 8 on the left, and then you have 8 on the right. When you simplify the expression inside here, it's just 8. Absolute value of 8 equals 8. That's 8 equals 8. True, right? So 0 works. 0 is a solution. All right, then I'll try x equals positive 16/9. So on the left side, you have the absolute value of negative 9 times 16/9 plus 8. And then the right side, you just have 8. 9's cancel here. You got negative 16 plus 8 is negative 8. That's the absolute value of negative 8 equals 8. And the absolute value of negative 8 is positive 8. So you get 8 equals 8 again. That works, right? So both of these work, and that's what I'm going to enter. All right, and it's really that simple. All right, get the absolute value alone. You're going to take the expression inside and basically say that expression inside is either the number on the other side or the opposite of the number on the other side. Solve and check. Right, and always check back in the original equation. All right, so 0 was a solution we saw, but it says select all that apply, right? And we also saw that positive 16/9 was a solution. Submit. All right, and after every question, whether you're right or wrong, you should be seeing a answer explanation. Please read through these. Okay, whether you're right or wrong, because you might be able to learn. You can learn why you were right, why you were wrong, and try to fix your mistakes in the future if you see any. All right, next question. Again, same objective. It's the one objective the entire time. Alright, so this one I gotta do a little more in the beginning, a little more moving terms around to get the absolute value alone. So you have 2 times the absolute value of x minus 6 plus 4 equals 7. Alright, so as I was saying in the steps in the previous page, this absolute value of x minus 6, the absolute value of an expression with a variable, I want to get that all by itself. So first I would subtract 4, and then we have 2 times the absolute value of x minus 6 equals, 7 minus 4 is 3, and then get rid of the 2 here, it's being multiplied, divide by 2. So we have the absolute value of x minus 6 equals 3 halves, or 1.5. Alright, now I have what I want, alright, to start with. Absolute value alone on one side, some expression, some number on the other. And then we break it up into 2 separate equations. Alright, the only way this can happen is if x minus 6, right, the expression inside, is either positive 3 halves, right, the absolute value of positive 3 halves is 3 halves, or if x minus 6 is the opposite of that, right, negative 3 halves, the absolute value of negative 3 halves is also 3 halves. Alright, and then we're solving each of these equations, and then going back, I'll go back to the original and check it. Now remember, when you add or subtract, you need a common denominator. This would be 3 halves plus 6, but 6 is the same as 12 halves. 3 halves plus 12 halves would be 15 halves, right, or 7.5. And then negative 3 halves plus 12 halves, right, plus 6 would be 9 halves, right, positive 9 halves, or 4.5. Alright, so and then check them. Alright, so I'm going to go back to the original. When x is 15 halves, 15 halves minus 6 would be 3 halves. The absolute value of 3 halves is 3 halves, times 2 is 3, plus 4 is 7. So this works. When x is 9 halves, 9 halves minus 12 halves is negative 3 halves. The absolute value of negative 3 halves is positive 3 halves, times 2 is 3, plus 4 is 7. Works as well. Right. Okay. So those are what I'll enter. Now they're listed here. 15 halves we saw was a solution. So was 9 halves. Right? And it just said select all that apply. Great. Alright, next. Same kind of question, an absolute value equation. Alright, so again, this is really nice where the absolute value is already alone. So I can just jump to those 2 separate equations, one with 2 and one with negative 2. So we have the absolute value of negative 3x plus 6 equals 2. So again, the only way this is going to be true is if negative 3x plus 6 is positive 2, or if it's negative 2, right? Because the absolute value of positive 2 is 2, but so is the absolute value of negative 2, right? So this negative 3x plus 6 could also be negative 2, right? And this would be a true statement. And then we solve each of these, and I'll check them mentally. If I subtract 6, that'll be negative 4, then divide by negative 3, we get x equals positive 4/3. Here I subtract 6, I get negative 8, divided by negative 3 would be positive 8/3. Alright, and again, don't forget to check them. Now when x is 4/3, you'd have negative 3 times 4/3 would be negative 4 plus 6 is 2. The absolute value of 2 is 2. 2 equals 2. That works. Sorry if I'm rushing this, but I'm just doing these mentally. 8/3. Negative 3 times 8/3 would be negative 8. Negative 8 plus 6 is negative 2. The absolute value of negative 2 is 2. You'd have 2 equals 2 again. Fantastic, right? So both those work. and this time you're typing the answer. They already have a comma there, so you're typing 1 in one box, 1 in the other box, right? So one of them was 4/3, and the other solution in the other box is 8/3. Wonderful. All right, and I should have one more of these, and again, I'm doing the same thing every time. The absolute value gets isolated. You set up those two separate equations, solve them, check them. All right, so this one, the absolute value is not alone yet, but it's pretty easy to get it alone, right? Add 12. Right, so I'm just going to do it on the same page. Just go to the bottom half of the page, and we have the absolute value of negative 3x minus 7 equals, minus 12, sorry. Minus 12 equals 9. Yeah, I would add 12 first to isolate the absolute value. Alright, so I have the absolute value of negative 3x minus 7 equals 21. Alright, 9 plus 12. And the only way this can happen is if negative 3x minus 7 is positive 21 or negative 21. Right? If negative 3x minus 7 were negative 21, this would also be true. And we solve each of these. So here I would add 7 to give me 28 divided by negative 3. So x equals negative 28/3, or negative 9 1/3. That's a possible solution. We'll check it. Here, if I add 7, I have negative 14 on the other side. Then divided by negative 3 would be positive 14/3. All right, and then again we'll check them. All right, so quick mental check. If x were negative 28/3, negative 3 times negative 28/3 would be positive 28. Minus 7 would be positive 21. The absolute value of 21 is 21. 21 minus 12 is 9. That is true. 14/3. Negative 3 times 14/3 would be negative 14. Minus 7 would be negative 21. The absolute value of negative 21 is positive 21. Minus 12 is 9. That's true. All right, so negative 28/3 and positive 14/3 are our solutions here. And again, they got the two separate boxes with the comma already, so just make sure you're putting them in their separate boxes if that's how they're presented to you. So negative 28/3 is one solution, positive 14/3 is another. There we go. Excellent. And again, please read through the answer explanations. And that should be it for this preview. Pretty short one, just one objective. And as I said at the top of the video, right, they're the questions I saw here. You may not be seeing those same questions when you go over the assignment yourself, but the objective is the same, so the types of questions should be similar. The way you work on them will be the same as the way I worked on them. So I'm hoping that watching me work on these helps you out in some way when you're working on the assignment yourself. And thank you very much for watching.